Okay, so what happens when we get a complex solution when we solve the quadratic formula? Well, remember a complex solution has real coefficients a and b. The I is the imaginary term, so we can write that as a plus or minus bi. They come in conjugate pairs. And we simplify it as a plus bi, but just remember this equals two different complex solutions, a plus bi and a minus bi. So in our example, it's already in standard form. We're going to use the quadratic formula. So a is equal to 3, b is equal to -2, c is equal to 5. So we have x is equal to the opposite, or negative b, the opposite of -2, plus or minus the square root of -2 squared minus 4 times 3 times 5, all over 2 times 3. Then we're just going to simplify. We have 2 plus or minus the square root of 4 minus 60 all over 6. And you see we're going to get a negative number under our radical. So this is our negative discriminant that's going to give us two complex solutions. So we have 2 plus or minus the square root of -56 all over 6. 56 is divisible by 4, which is a perfect square. And we're going to simplify that into 2 plus or minus 2 times the square root of 14i, and the I is outside the radical, all over 6. And for us to get it into the standard form for a complex solution, we need a separate a and a separate b. So we're going to divide both terms of our numerator by 6 and simplify. So what we end up with is 1/3 plus or minus the square root of 14/3 I. So then our a value is 1/3. Our b value is the square root of square root of 14 over 3. Let me correct that. So the square root of 14 over 3, and then we have our I term. Sorry, don't want that to look messy. And then this is our final solution. There are two complex solutions for our quadratic. So let's summarize some of the things that we've gone over. Some methods for solving quadratics. If our b value is 0, we can isolate the x term and we can use the square root property of equality. If we have a c value of 0, we can factor out the greatest common factor. And then we can solve using the zero product property. I always like to abbreviate that ZPP. It's kind of long to say and to write, so if you ever hear me say ZPP, zero product property. And then if we have no coefficients that are 0, then we can solve by our different methods of factoring the trinomial that we have. We can use completing the square, or we can use the quadratic formula.